Yes, hello children. Today our topic is Arrhenius theory. Okay, this theory was presented in 1884. Okay, according to this theory, an acid is a substance, okay, that gives H plus ions when dissolved in water. Okay, acid is a substance that gives H plus ions when dissolved in water. Here example, okay, HCl, CH3COH, acetic acid, okay, H2SO4, H3PO4. These are, we can say, examples. Okay, how these are producing H plus ions? Okay, suppose HCl when dissolved in water, okay, to form H plus ions and a Cl minus ions. Okay, HCl dissolved in water, it produces H plus and Cl minus ions. Okay, similarly acetic acid, sulfuric acid, okay, these all also. Yes, next, base. Okay, a base is a substance that gives OH minus ions when dissolved in water. Okay, what are the examples for bases? Okay, base is a substance that gives OH minus ions when dissolved in water. Examples, NaOH, KOH, CaOH twice, like this compounds. Okay, here for example we are taking NaOH dissolved in water. Okay, it produces Na plus and OH minus ions. Okay, suppose here amphoteric substance is also there. What is amphoteric substance? Okay, amphoteric substances, these are furnishes. Both H plus and OH minus ions in the aqueous medium. For example, here water produces both H plus and OH minus ions. Okay, water exists in the form of H plus and OH minus ions. What is Arrhenius neutralization? Okay, what is Arrhenius neutralization? Okay, here we can say acid and base. Okay, for example, hydrochloric acid and sodium hydroxide, acid and base reacts to form salt and water. Okay, this neutralization reaction we are calling as Arrhenius neutralization. Okay, how we can say this? Simply, the combination of H plus ion and OH minus ion, okay, to form water molecule. Okay, this is called as Arrhenius neutralization. Okay, this is about what is Arrhenius acid and what is Arrhenius base, what is amphoteric substances, okay, what is Arrhenius neutralization. Okay, completed here. Then we will see what are the limitations of Arrhenius theory. See, What are the limitations? Okay, first one, this theory is applicable only for aqueous solutions. Okay, this theory applicable to only aqueous medium, but not to non-aqueous medium. Okay, that means it is only applicable for aqueous solutions. Okay, it does not explain about acidic and basic nature of non-aqueous media. Okay, second one, it could not explain the acidic nature of non-metal oxides. Okay, it could not explain the acidic nature of non-metal oxides like CO2, SO2, SO3, Cl2O, N2O5 and etc. And basic nature of okay, ammonia and H3, metal oxides like calcium oxide, sodium oxide, magnesium oxide and etc. in non-aqueous medium. In non-aqueous medium. Okay, but it can explain in aqueous medium. But it can explain in aqueous medium. Okay, next third point is he failed to explain acidic nature of certain salts. He failed to explain acidic nature of certain salts like AlCl3, BF3, BCl3, FeCl3 and etc. Okay, in aqueous solutions. In aqueous solutions. Okay, this is Arrhenius